This is lesson 113B, the second part in Algebra 2, going over logarithms and anti-logarithms. So again, let's say that we have 10 to the 4.316 power. Alright, we're looking for what that equals. That is the anti-logarithm. Alright, there's no formula or no symbol. Like we have natural logarithms like this and common logarithms like this. There isn't a symbol for anti-logarithms. So we just figured that out. And the way we do that is we type in 4.316 and then we hit the 10 to the X key, and usually that is the button right before or right above the log key. So you'd have your log key and then you'd have 10 to the X power right there, so you'd have to hit your shift key or your function key to do that. So you'd type that in and then click on that button there, and that would give you the answer. The other option would be to use the Y to the X key, and then you would put in 10 and then click the Y to the X key and then 4.316. I mean, either way is going to give you the right answer, but I prefer you use this here simply because you're getting used to that whole idea of anti-logarithms. So what we've got here is we've got log 100 equals 2. Alright, so if you want to find the log of 100, all you have to do is type in 100 and hit the log key. Okay, and that's finding the logarithm because we're looking for the exponent to put on 100. If we're looking for the anti-log, let's put the same thing here. We are now looking for this number. So we type in 2 10 of x, and that will give us 100. Because what happens here is on your calculator it's saying 2 is going to go in the place of x here, so 10 to the second power is 100. If this were a 3, 10 of x, you should get 1,000 because you're putting a 3 on that x, and you'll get 1,000 for an answer. Okay, so let me write here log, maybe this will help, 10 100 equals 2. Alright, if you are not given this number, you use logarithms. If you are not given this number, you use anti-logarithms. Okay, so this is for log and this is anti-log. So it just depends on what you're looking for. If you're looking for the answer for 10 squared, anti-log. If you're looking for the exponent to put on 10 that's going to give you 100, you're using logarithms. The same is true with natural logarithms if you're using ln. The exact same rule applies. And you can use ln or log depending on which one you want to use. So for example, let's jump to 113.2 here. Okay, so let's look at this problem here, example 113.2. You could take your calculator and just multiply this out, but what we're going to do is we're going to use logarithms. So this is what we're going to do. We're going to take the log of 47,832 and the log of 59,463 and over the log of 0.000817. Alright, now I know this seems a little bit longer method of doing it, but really when you start getting into logarithms better, this is a very fast way of doing it when you get into some other things. So when you take the log of 47,832, what does that mean? That means I'm going to change this to a 10 to some power. That's all I'm doing. when I take this, I'm saying I'm going to change 47,832 to 10 to some power. So I can rewrite it as 10 to some power. In fact, I'm not even going to write the power because remember I said a logarithm is an exponent. So I know the 10's there, so all I'm going to do is write the exponent. So here we go. Type in log of 47,832 and you're going to get 10 to the 4.68. Okay, so when you take log of 47,832, you're going to get this number, but because the base is 10, we're going to go ahead and write that. So we got that. Log of 59,463, we get 10 to the 4.77. Okay, notice that these numbers here are not too far different. You know, 47,000 to 59,000, they're somewhat close. This one's smaller than this one, so the exponent is going to be smaller than this exponent because this isn't going to take as high of a number to get this back. 10 to this power equals this, 10 to this power equals this. Since this number is bigger than this number will be bigger than that. Alright, and we'll put it over the log of 0.00817. Now one of the things that you'll notice is that when your numbers here are less than 1, your exponents are going to be negative. Because remember that negative means that, right? Okay, which is smaller than 1. So anyway, we get that. Alright, and because our base numbers are the same, we're going to use our method of exponents, which says if we take 10 to this power times 10 to this power, it's the same as okay, and then I'm just going to leave this as is right now. Alright, let's move this up. So you notice all I did, let's see if I can get this all labeled here correctly. Okay. All I did here was added my exponents. Again, I'm using exponents. So take these two and add them together. So we have 4.68 plus 4.77. And I get 10 to the 9.45 over 10 to the negative 3.09. Now remember, when you divide exponents, it's the same as subtracting. Okay, so I'm not only subtracting, I'm subtracting a negative, right? So that's going to be plus. So I get for my answer 10 to the 12.54. Okay, so I have 10 to the 12.54. What does that equal to? Well, if I just take 12.54 and click my 10 to the X button, I will get 3.47 times 10 to the 12th. Okay, so really this is the answer, but it's not really a usable answer. I don't know what 10 to the 12.54 is, but this gives me a little bit more of an idea, putting it in scientific notation. Okay, so we took the logarithms of each of these numbers up here in black that we did at the very beginning, you know, the 47,832, etc. We took the logarithms of those, and then we took the anti-logarithms right here to go back. So when you take the logarithm of something, usually you'll take the anti-logarithm once you've solved it in order to get back to the exponential form that you started with. So we started with just regular numbers, 47,832 times 59,000, etc. We took the logarithm of each one, and we were able to simplify, and then we took the anti-logarithm of that answer to get us back to the original form that we were in. So that's a good thing to remember there. So let's look at 113.3. Alright, what do they give us there? 47,832. So this is the exact same problem we just did, and we're multiplying that by 59,463, and there's a reason for this. Alright, over 0.000817. Alright, so what we're going to do here is, instead of using logarithms, we're going to use natural logarithms. So instead of log, we're going to use ln. Okay? So in the last one, we took the log of 47,832, etc., etc. Now what we're going to do is, instead of the log, we're going to take the ln of 47,832 times the ln of 59,463 over the ln of 0.000817. Okay, so we do the exact same thing. We take the ln and we get an exponent of 10.78, and for the other one we get an exponent of 10.99, and for the bottom we get a negative 7.11. Okay, those are our exponents when we take ln of each of these. Alright, but remember on the logarithms what we did with this was we had a 10 there, and a 10 there, and a 10 there. Well, dealing with natural logarithms, you don't have 10s. Remember, you have e's. Everything works the exact same way, but we have e's now. We add these together, and then we subtract that, that means you minus a negative, so we're going to get e to the 10.78 plus 10.99, and then we're going to subtract a negative 7.11. So subtract a negative is the same as adding, and we get e to the 28.88. So if you take your calculator and you put 28.88 in there, and you hit your shift key and then the e to the x button, you're going to get 3.49 times 10 to the 12th. Okay, so notice that our answer in our first time we did this was 3.47 times 10 to the 12th. So these are basically the same number. The only reason we have a different number here for our 9 and our 7 is just because of the error in your calculator. You know, it only goes so many decimal places using that E key, so it kind of makes things a little tiny bit off, but that was just to show you that whether you use the log or the ln to figure this out, you're going to get the same answer. Same method is followed. We go from exponential to logarithmic, get our answer, to here, and then we go from logarithmic back to exponential, okay, by clicking on the e to the x key. So what is the answer when we take e to the 28.88 power? And remember, e is that weird freaky number 2.71828188285. So that number to the 28.88 is what we did here in order to get this there. Okay, so I hope that makes a little bit of sense here. Let's go and do one more video and do some practice.